Good morning, everyone. Good morning. Vikram, good morning. Sri Charan, good morning. Yeah, voice is clear. Am I audible to everyone? Yes. So just remind me yesterday where we stopped our discussion. The class ended with the point where we completed our class. That is ray diagrams of a concave lens. Is it any other discussed ray diagrams? Right. So now here just I'll remind you last situation of the concave lens ray diagram. For any situation, we generalized one thing. What characteristics of the image formed by a concave lens always diminished, virtual, erect, and the location is between pole and the focus. So once look at this, here the object is placed between pole and focus or focal point and optic center. So for that, just you are following the logical rules, identifying the center of curvatures and the focal lengths, then placing the object facing upward direction above the principal axis, then select two rays from the top of the object. One is parallel to the principal axis and the other is passing through. So here when the ray incident on a concave lens parallel to the principal axis, after refraction it appeared to diverge. So how to trace that path? Just connecting the point of incidence and the focus. Then extend that light ray after refraction. Second ray passing through optic center. We know that behavior of light ray, it remains undeviate after a refraction. Right? So this is clear, everyone, up to this point. Yes, so there is no confusion left in drawing the ray diagrams. I said to practice the ray diagrams. How many of you completed drawing ray diagrams? How many of you? Just raise your hand. How many of you completed? Raise your hand. Practiced ray diagrams. Abhinay completed. Two members, Medhasri and Surajita, Sri Charan. Okay, Vikrant, did you practice? Yes. So no confusion left. Lower your hands. Lower your hands. Okay. Then here, now we are going to another topic, example 4 and example 5. Before going that, just I will remind you what that special situation we discussed. Can you remind me what is that special situation? Special situation we discussed. What is that special situation? Anyone? Remind me that special situation. What are the four situations? Situation one is along the principal axis, right? So along the principal axis. Second situation is passing through pole. Third situation is passing through focus. Situation 4, am I correct? Can anybody remind me that situations? Open your textbook. Are these correct? Let us check. Anyone? Open the textbook. What is situation 1? I think along the principal axis. Second one is through pole. Third one is parallel to principal axis. Fourth is through F. I think these are correct. So 4 situations we discussed, right? Other than these situations, special situation discussed that which do not meet any of these situations, right? That is making angle with the principal axis. Parallel beam of light rays making angle with the principal axis. Once I will remind you how to deal that situation, because example 4 and example 5 based on that concept only. So here what happens when parallel rays of light fall on convex lens making some angle with the principal axis. So here convex lens I am taking and identifying its center of curvature, pole and focal points, right? So completed. Then line joining them is called the principal axis. Now selecting the parallel beam of light rays that making angle with the principal axis. So in this situation, how to know this behavior of these light rays, especially we know this light ray behavior because it is going to meet one of your situation 2. Situation 2. Can anybody complete this? Help me how to complete this ray diagram. Among these 5 rays, which numbered ray meets the situation number 2? Second ray or third ray or fourth ray, which one? Shall I give numbers here? First, second, third, fourth, and fifth. See here, third ray. It is passing through pole. What is its behavior? What is its behavior? This light ray after refraction. Will it deviate from its path? Are you here?
Yes, undeviate.
Remains?
Undeviate.
Okay, remains undeviate. So first of all, you need to complete that light ray behavior by placing your scale like this, right? Then drawing the perpendicular onto the principal axis, right, through its focal point. So F1 is focal point for any lens. Remember, F1 is focal point for any lens. So here I drawn a vertical line passing through F1. So this is called a focal plane, right? So this is your step 1. Finding the focal plane and where they coincides each other. That point we can recognize as here imaginary focus. Then drawing all the light rays towards that imaginary focus. Is it clear? For that also I have given that why we are selected. Why we are selected like that. See here. If you change the angle with the principal axis for any angle by the parallel beam of light ray, after refraction, the converging point lying on the focal plane. This is the reason to select this imaginary focus. Is it clear, everyone? Clear? So now we will see in case of concave lens. In case of concave lens, what happens when parallel beam of light ray fall on concave lens, making some angle with the principal axis. So concave lens is taken, identifying its center of curvature, pole and focal points, then selecting the light rays which are parallel to each other but making angle with the principal axis. In this case also, we know one of the ray which meets our situation, that is passing through the pole. So first complete that ray behavior after refraction, remains undeviate. Then drawing the focal plane from its F1 perpendicular to the principal axis. So this is focal plane. Then the ray which is passing through the optic center, which remains undeviate after refraction, that where it meets the focal plane, that is imaginary focus for us. So So that red color spot on the focal plane is taken as imaginary focus. From there, I am connecting all the point of incidence for the respective light rays. Then after refraction, they appear to diverge or emanate from the focus. So completing that light rays, extending in the same direction, straight with the dotted lines. Is it clear, everyone? I'm using this knowledge in solving the example 4 and example 5, right? So now here, look at that. Why I decided that behavior of light rays like this. So I have one observation, that is here, look at in the animation. So for any angle made by the parallel beam of light ray with the principal axis, the diverging point will be lying on the focal plane. This is the reason to generalize that behavior of light rays, right? So here the middle line is acting like principal axis, imaginary principal axis, right? The ray which is passing through the optic center, that we are considering as imaginary principal axis. If you are clear, I'll go to example 4. Any confusion in this special situation? Nothing, right? So we'll go for the another, that is example 4 here. So what is actually example 4? Here, simply you need to draw the ray diagram. For what situation? An object is placed on the optical axis MN, right? What the height is given for that object? Point size, right? But when you learn the ray diagrams, you learn the ray diagrams construction using the height of the object, width of the scale. But here there is no height for the object. Then how to deal this situation? Already we have learned in deriving the curved surface formula. Then again I am reminding you how to deal in case of lenses. So here, draw a ray diagram to locate position of image when a point source S is placed on optical axis MN of a convex lens in such way that it is beyond the focal point. That position of object is also given beyond the focal point. So for that, just you are understanding the figure E, which is given in your textbook, right? So I'm drawing that figure E. So first of all, I need lens. Which lens? Double convex lens, because suggested as convex lens. Then identifying its pole, then drawing a line called principal axis, identify its focal points, right? Optical axis name is given, so that's why I named that horizontal line as MN, optical axis or principal axis. Then identifying the focal points as F1 and F2 respective to the lens, and the midpoint on the lens is called pole. So completed. Next, here clearly mentioned where you need to place the object beyond focal point F2, right? That source is point source. Object is what? Point source. So here take the point source object beyond the point, focal point. So here I am naming that as O here, or you can name it as something S also, no problem. Any name you can give, right? So point source object S is placed on the principal axis beyond its focal point F2. Then here I need to get image point for the S after refraction, where it will be. So for that, I need to consider the light rays which are started from the same point of the object. Here source is point object. So from the same point, you need to select two rays that which meets any situation. Two rays must be meet situations. So here 4 situations are there. Here 4 situations are what? One is passing through F. One is passing through optic center. One is parallel to principal axis, and the other is it is the other is along principal axis. So how many of these situations help you here? Which situation you can consider in this situation? Anybody? From the point source object, yes. Which situation help you here? Two or only one? Can you take more than one situation here? Not possible. So only one situation is possible, that is along the principal axis, right? So for the second situation, I am selecting a ray making angle with the principal axis here, right? That is going to meet the lens at a unknown point P dash, unknown point P dash, right? Then here, simply, what is your second ray? It is along the principal axis, remain undeviate. Look at that. Second ray is considered, it is remain undeviate after refraction. Can you see that ray? Right? So this is second ray. So R1 is making angle with the principal axis. R2 is along the principal axis. It remains undeviate. No deviation in this case. Then what about this second one? This ray behavior. This ray behavior. Can anybody? How it behaves? Does it meet any situation? Situation 1, 2, 3, 4? No, doesn't meet any situation. So in this case, we need to make it this ray R1 parallel to the principal axis. Parallel to the principal axis. So here we are unable to use original principal axis. We are unable to use original principal axis. That's why I am using one of the situation called, that is passing through pole or optic center. What is its behavior? This ray
remains undeviate.
Remains undeviate. So here, for that purpose, see here how I am drawing that. Exactly parallel to this. Exactly parallel to the ray R1. I am drawing a line passing through the optic center. So place the scale like this. Place the scale like this. Okay. Then draw a line. Now look at how they are. They are parallel or not? Are they parallel or not? This red color line is what for us? This is imaginary optical axis is M dash N dash. Imaginary optical axis using is M dash N dash. So now look at R1. How it is parallel to the principal axis M dash N dash. What about its behavior after refraction from the convex lens? Can anybody? We know the behavior of this R1 now. Express how it behaves. After refraction, it converges or diverges through the convex lens. It converges. Where? Exactly on the focus. But where is focus here? Do you see any point located on the red color line? No. So I need imaginary focal point. Imaginary focal point. So what to do? We need to construct the focal plane. So use F1 as focus on the principal axis Mn. Then cut a line perpendicular to the principal axis Mn, as you see here. This is called focal plane. That red color imaginary principal axis and this focal plane, where they coincide, that point is here imaginary focus, given as F0. Then your ray meets the principal axis exactly at focus after refraction. So here this R1 meets the point F0 because it is parallel to the imaginary principal axis. That's why it meets the imaginary principal axis, but we don't consider these point is image point. Why? This F naught is not image point for me. What is image point? That two light rays after refraction where they are going to meet or coincide each other, that green color spot is taken as image point is something I. So point O image is obtained at I. So now we completed that diagram. Is it clear, everyone? How to understand that example 4? Everyone is clear? Rohit, Tejashwini? Right. So now we'll go for example 5, similar to this one. After completing example 4 and example 5, I will give you 2 problematic diagrams. Right? Then look at here example 5. Already direct figures are given, right? Complete the ray diagrams to show the paths of the rays after refraction through the lenses shown in the figure E5A and E5B. So what is E5A? Like this, right? So here, what is E5B? It is given like this. Does it meet any situation that light ray be given as incident light ray in the figure E5A and E5B? Does it meet any situation? Are you following? Just respond or use your quick reaction as no or yes. No one. Okay. So here, do not meet any situation, because here that situations I know, passing through optic center along the principal axis, parallel to the principal axis, and passing through focus. So it is not passing through focus, not passing through optic center, not parallel, and not one more situation. It is confusing me. Right? Not parallel, not passing through F, not passing through focus, and not along. Right? Not along. So not possible to draw directly here. So we are depending again on the imaginary principal axis and imaginary focus. If that given light ray does not meet any situation, immediately you need to draw the imaginary principal axis for the given light ray. Are you clear? The first observation point is it meet any situation or not? If does not meet, go directly constructing the imaginary principal axis and imaginary focus. Then what to do? I'm taking the convex lens here, identifying its pole, then drawing the principal axis. After that, identifying a original principal axis focal points as F1 and F2, then given ray constructed as given in your problematic figure. Clear? Rough diagram is drawn. After this, what to do? Here I need imaginary principal axis. How do you construct the imaginary principal axis? Imaginary principal axis passes always through the pole. But that condition is what? It must be parallel to the incident light ray, right? Not the given light ray. It must be parallel to incident light ray. Sometimes they may give you refracted light ray also. We need to check that given light ray is incident or refracted. Is it incident or refracted? Excuse me. So here given light ray is incident light ray. Now I am constructing parallel ray that which is passing through the pole. So place your scale as you see here. Then construct the ray or line called as imaginary principal axis. This is what? Imaginary principal axis. Then after completing this, what to do? What to do? Anyone? One step completed.
Constructing focal plane.
Where? Where? At any point? Exactly.
F1.
F1, right? Perpendicular to the principal axis. So place your scale as you see here, then construct after this simple imaginary focal point. That imaginary principal axis and focal plane where they coincide, that point is imaginary focus, F0. Then draw the refracted light ray by connecting point of incidence and imaginary focus, extend it to meet original principal axis, right? So this is the behavior of given incident light ray after refracting from the convex lens. Any confusion? Is it clear? Right. Now another figure is given with the concave lens, right? So now going for that, concave lens is drawn and pole identified. Next, identify its focal points on the principal axis, original principal axis. Then construct given incident light ray. Then what to do? Draw a focal plane. Draw a focal plane here, right? By drawing the focal plane, what to do? We have to make this incident light ray before refraction parallel to the principal axis, right? Before refraction parallel to the principal axis, then it meets the situation. Then it meets the situation 3 here. So what to do? Just place your scale, then draw a line from the focal plane, right? Before the lens, show that eyes dotted line, right? After you can construct a line, then remove your scale. So where I got that line passing through the pole coincides with the focal plane, that point is imaginary focus, right? Now look at your incident light ray, something R1, how it is, right? How it will be with the principal axis. It is looking like with imaginary principal axis, how it is that given incident light ray R1. Is it looking like parallel or not? Is it parallel or not? Yes, parallel. Then what to do in this case? We have to construct situation 3, right? After refraction, it seemed to be emanate from the focus in case of concave lens. So connect that imaginary focus with the point of incidence as you see here. Connect imaginary focus with the point of incidence as you see here. Then what to do? Just extend that in the same direction as you see by joining that line with the scale, then extend it. So this is the behavior of light ray after refraction. So completed. We have completed that behavior of light rays. Is it clear, everyone? It will confuse you, right? It will confuse you when I change the question. Be careful, right? I'll change the question now. I'll give you practicing question, right? So take a rough note. Take a rough note and note down the problem figure, right? I'll give you such a lens called, what lens is this? Double convex lens. So here its principal axis is this one. Then I'm giving you a ray which is behaves like this after refraction. Then how do you complete this one? Is it clear? Problem figure, how to draw? Have you noted down? Noticed? Completed? If it is completed, I will clear this. Okay, I'll give you another problematic figure which we construct in case of double concave lens. So lens type is now concave lens. Then I'm showing you its original principal axis. Then the behavior of light ray I'm giving you like this. After the refraction, that exactly passes through the focal point F2 after refraction. These are the problem figures. Right? Don't try for them. Try to understand the given situations. Special situation is given, and example 4 will help you how to complete this. Are you clear about the problems? Example 4 and example 5. In these situations, what I am given for your practice, in this, am I given the refracted ray or am I given incident light ray?
Sir, refractory.
Refracted ray is given, right? Think before you complete the ray diagram, right? What to do, right? So if you complete these, you are clear about that. Example 4 and 5. Okay, so let us move to another topic. After this, what we have, the topic is here lab activity. What we have? Lab activity. So here, what is lab activity? Simply finding the focal length and observing the characteristics of a image formed by that, right? So in this, you are measuring the object distance and image distance to observe types of image formed by a lens, right? And measuring the object distance. We are not measuring object distance, always we are selecting. This will be fixed. What we are selecting, that value is only for respective u value. What will be v value? That we need to measure. Then note down that characteristics. So this is lab activity, right? The next, for conducting any lab activity, what we required? Materials. So what are the required materials here? So first you required a lens, that is convex lens. What the lens is? Convex lens. To place the lens, we required a stand called V stand. Then a source is required, eyes object. Eyes object, I am using the candle, right? Then to measure the distances, I required a meter scale or the scale. So tape or the scale. Tape or the scale. Then to light a candle and to observe the image, you need screen and matchbox. To observe the real image, we need a paper, and to observe, to light a candle, I need matchbox. These are the minimum required materials. These are the minimum required materials. Then before starting the procedure, we need to know the precautions. What are the precautions you may take here? Can anybody? What precautions will follow here? What are the precautions? Here precautions are simply what you are measuring, object distance, image distance. So here try to measure them somewhat accurately, right? Try to take as much as possible accurate values. Then we are using the screen. You are moving the screen here and there. In that process, you need to observe or obtain image on the screen, sharp image, right? Then using the screen below the principal axis, right? So this type of precautions we will take. So here selecting the lens with the non-focal length first, with the non-focal length, then obtaining the sharp image on the screen, measuring the distances accurately, right? Then observations noticed in the table, because I am going to measure the distances. What that? Object distance, image distance, u and v. That I need to tabulate. That means notice that values in the table, right? So that table is like this. Then finally you are finding the focal length by giving a relation between u and v, right? By giving the relation between u and v, or using directly formula 1 by f equal to 1 by v minus 1 by u. We will derive this formula in the next class, right? So these are the precautions we follow and noticing that observations in the given table. After completing the table, you are going for generalization, right? So procedure is there. Before that, I'm telling you what the remaining steps are. We will conduct the activity, okay, by following the table to note down the observations, right? So except that procedure, I am giving you all the remaining things. So aim completed, required materials completed, precautions completed, tabulating the values completed, then generalization. Finally, what you are giving, right? So that steps we need to complete in this lab activity. So after this, we'll go for procedure. So procedure will be start just within 1 minute. I'm ending this meeting. Join in the next meeting.